symbols.
Maybe it could be a truck. You have one reader per truck.
Yeah.
That type of setup.
Yeah.
Okay.
So first, in the first phase, we just test the different material the items. For example, the wood, glass, clothes, books, water, plastic, and some iron and cotton. And we also do some experiment for the same material item. For example, we check the four types of cell phones. And we found that because the shape of the iPhone 4 and the HTC, this cell phone is very similar. So the difference is very small. However, if we test another cell phone, another Huawei cell phone, so the size and the shape is very different. So the feature is also very different. So we can do the.
What is the y-axis? What values are on y-axis?
The y-axis actually is some values we extracted from the signal features. For example, the RSS, the phase. So it's actually we.
So you use the RSSI and phase?
Yeah,
okay.
RSS phase. Yeah, this kind of values. This signal actually was is collected by the USRT platform, so we can get this kind of value. Okay, so this is one of my ongoing work. Another ongoing work is we call it intention localization. So maybe it's slightly different from the behavior or location identification or the behavior identification. So what means of the intention localization? So basically, currently we are conducting a project called 973 program in China. So this is a very huge research project in China, and this focuses on the actually the interaction between the brain and the machine. So we want to get the intentions from brain. This is our ultimate objective. I was also involved in this project. Okay, so I'm thinking how to get the intentions from the people. So because we have a lot of devices, and actually we have our intentions when we operate those devices, right? So, we want to do something different. So traditionally, we can interact with the machine system using the conventional human-machine interface. We call it HMI. So basically, we can have a keyboard, we can have mouse, we can have a voice interface, or the touch. Right? However, this kind of channel, so basically, we need to involve the people in. So we need to mutually to operate the device for the interaction, right? And we also need to do some information transformation between the human and the machine system. Actually, the communication channel of those kind of systems is very narrow. So in our project, we have another solution. We use actually this totally different from our computer science guys. So they use some specific equipment to get a signal from the brain. For example, we use the fMR, we use the EEG to get the brain signals, and then we want to do some encoding or decoding between the signal and the real intention. Okay. Right. However, currently the result, this kind of a BCI, we call the brain computer interface, this system are very simple, and they can only get the very simple control on the external devices. So we want to set up some direct system. We want to set up some system to directly get the intention from the people. We want to answer the following questions. Can we sense the intention? And what does the user care about? And finally, we want to know what the user want to do. This is our objective. So firstly, we focus on the visual channel. So the Sugang actually I think you do the same job, right? You put some you use the Google Glass. And in last year, Zhang Lan, previously she and me were in a same group. So she developed some Google Glass-like devices that put some camera on the glass, and then they can detect and track the movement of the eyes. And then
Can I ask one thing? How this is being used for targeting in F-16 for the last 25 years.
yeah.
So why do we consider this?
For this mobile com.
But it's
This is commercial technology you can buy.
Yeah, that's what I'm saying. It's a mobile com, right? They do not necessarily have the latest technology, but they have the coolest toy.
Okay.
okay.
Sorry.
So actually, all those techniques have been deeply studied and developed, but we want to use it in a more commonly. So this is our idea. We want to use the mobile phone to achieve the intentionalization.
Really? Can you do that?
Yeah, this is the idea. So for each cell phone here, especially for the smartphone, we have two cameras. The front camera and the rear camera.
Oh, so you want to detect what the eye is gazing at?
Yeah, so we can use the front camera to track the movement of the eyes, and we use the rear.
Definitely, sure. Yeah.
Use the.
But what your eye is looking at is not the same as what your brain is thinking of.
Oh, I think this may be my second step for getting to distinguish what is the real intention, what is not the real intention.
Yeah, I still think EEG is very critical in this sense.
Yeah. Very good question. Okay, so this is our idea here, and so next is just very concrete steps of our works. So we just do some step-by-step identification. So finally, we want to estimate the gazing direction and the distance between the object and the cell phone. Okay, so we can do the intentions.
Yeah, I read a work, I forgot from somewhere, but basically they are using exactly the same technology to diagnose autism at a very early stage. So basically they are saying if a kid has autism, when they look at a picture, they do not stare at the subject that a normal kid usually stares at. Let's say if you have a picture of a child or a flower, a normal kid usually either looks at the child or the flower. But the kid with the autism may be looking at the sky or you know, something else.
This is really actually this application is also our potential target.
Yeah, they have developed a toolkit on iPad.
Yeah.
So basically they want to see if I give a picture what this kid is looking at by using the camera on the iPad. So it's basically very similar to this.
Yeah.
And then using that tool, they can try to diagnose whether the kid has autism or not.
Right. So I'm currently cooperating with some hospitals in China to do this kind of research. And we want to realize our research in the mobile platforms.
Right. You probably want to dig out some research because people were criticizing that type of work has been done in some areas. Like you need to have some improvement on that.
Yeah. Right. Okay, so just quickly go through the technical part of my work.
Sure.
Okay. So firstly is to detect the face. Okay, so this is the first step. Different from the traditional cascade of the detectors. We use actually just 7 points in the face to localize the face first. And then we can use the 7 points to represent the movement of the face. Okay. This is the first step. Second step, we need to outline the iris contour, the area. Okay. However, this is also very challenging because it's not a perfect circle because the ellipse. Okay. So the second step and the third step, we need to locate the center of the iris. This is the third step. So finally, we can set up the model. So among the iris, cell phones, and the targets. So we can calculate. We not only use the 2D model, but we also use the 3D model to calculate the distance as well as the directions from the cell phone, actually from the user to the object. Okay, so this is what we did, what we've done in this research, and this is our demo in the mobile platform. So maybe I think the most challenging thing is that we need to solve the problem such as hand shaking. Okay, so because you need to raise your head to put your cell phones here, so you need to solve the problem of shaking. So basically, we can guarantee that
you can find
the center can be accurately detected in a real-time way. So this is our work. Okay, so the next ongoing work is the gate. We use the gates as a biometric. We can use it to do the authentication. Okay, so basically this is a kind of a dynamic authentication. So imagine it. So if we just use a fingerprint, so actually it's very easy to duplicate, right? Or you can just cut off your thumb and then you can do the authentication. But if we use this kind of technique,
this is called a behavior biometric.
Yeah. So okay, so story is very easy to be understood. So I just skip it. So just go to the real story of our research. Currently we use the stimulus triggered gate biometric feature. That means we first show a stimulus in the screen of the cell phone. For example, a circle, and then we move a small ball. We let the small ball to move along the circle, okay, and then we detect the actual trace of the eye.
So how a person actually moves her eye.
Yeah. And then we extract the features for each individual users. Okay.
What feature? Which sensor are you using?
No, just the
gaze.
The track.
The trace.
The tracing, yes.
That's what we want to. That's what we are doing now.
Okay.
So basically, we want to first we want to try to find as many as possible features, effective features, and then we want to know which feature is optimal for this kind of authentication. This is what we are doing. In current phase. So this is some preliminary result of our research.
So basically, you have a few shapes.
Yep.
You want to see how the eye tracks the shape.
This is 3 different persons, three different volunteers in our lab. We collect the traces of their errors. Okay. So they're totally different for the same trace. This is a very standard trace. Yeah, actually the stimulus, and this is the trace from different users.
Okay, so here there are 2 things, right? You want to prove whether this is repeatable and whether this is distinguishable, right?
Actually, they have improved. No, we just want to improve the efficiency.
It has been improved by.
Actually, we do not know which feature or what group of features can be used for to be the most effective. This is the work.
About what has been improved.
Okay, so our lab maybe have our lab has 30 or 40 students,
Okay.
and we ask them how to be involved in this experiment.
Okay, so basically, so you said that you. That's fine. That's what we do here too.
So we do a lot of experiment on this this work.
Right, right. So basically, you have 30-something subjects,
Yeah.
and you show that they're repeatable and distinguishable.
Yeah. So maybe we need to involve more, invite more volunteers to be involved in this project. Maybe 100 or 200 from my class. Okay, this is something we want to do in the PCI actually. Shift interference. Okay, so this is we also want to do some other applications, but it's maybe in the future. Okay. Okay, this is a vision of this kind of application. Okay, the second channel I want to use is a wireless signal. It's more related to our to your research, I think. Okay. So this is also use passive tags, battery-free passive tags. We want to do the intention detection. So actually the idea is also very simple. We want to use the RFID tags to detect the movement of the for example the arms of the user. Then we can do which direction they want to move, and then deduce the intention of the user. Okay, but we will do it in a device-free pattern. So if we can realize this kind of system, actually we can help some people with some problem in their eyes. Okay, for example, they cannot see the stuff, but they can only touch the item. Okay, we can help them to get the things they want to they really want to get. What's his real target? Okay, and for some small child, we can avoid to touch the danger points or danger area. Okay, so we do this research in two phases. First is the gesture detection, and then we do the intention detections. So I just see the main idea of this research. Okay, so we have the following observation. So if we detect the signal of the passive tags, and we find the signals will vibrate as the head approaches to the tag, or depart from this tag. So these two train of the in this scenario. Okay. So when we approach to this object, so this object was attached by an RFID tag. Okay. When we approach to this object, the change of the signal, for example, the amplitude of the signal, actually the vibration of this change will be increased. When we move our arms away from the object, actually the change will become smaller and smaller.
Sure.
Okay. This is the real experimental result. Yeah, this is the increasing and decreasing. So this is the basis of our idea. And next, we just use this model to do the direction detection and the the gesture detection, and then the intention detection. This is the main story. Okay, main story. However, we need to solve some challenge. So the first challenge maybe we need to consider the scenario of multiple tags. So for example, in a shelf we have multiple tags or many tags, right? We need to distinguish them. Okay, because we need to collect the signal. So we need to use the signal to we need to distinguish those tags from just based on the signals, However, for some tags, this is the change of their signal is very similar. So how to successfully to distinguish those signals? This is maybe the first challenge, and we also need to realize some components used in the commercial readers. However, we need to realize it in the USRP platform. This is also very challenging. Okay, so this is just a technical work. And we also need to extract some fine-grained features. Okay, to accurately represent the real intention of the user. Okay, this is our ongoing work. Yeah, and the final, or no, maybe not the final. The next step application we want to utilize those techniques is this. We want to do some wildlife protection in China. Yeah. And
In device
the first target is this
Right.
monkey, this very beautiful monkey. It's called golden snub-nosed monkey， 中文叫金丝猴啊，英文实在我不知道怎么讲。This kind of monkey is a very endangered animal. Endangered animal. Totally, there may be only 500 to 1,000 animals in
Yeah, they're very cute.
the entire world. Yeah. So just before my traveling here, we go to the Qingding Mountain. Qingding Mountain in Shanxi. Yeah. So go to the environment. They are living in the environment of those monkeys.
Yeah, they live very close to my hometown.
Yeah. And actually, we want to do the behavior detection for those mountains.
RF signal.
Yeah, we want to do a hybrid detection. For example, we use the traditional video camera as well as a device-free.
So you're actually not doing
Yeah.
things like sensor, right?
Mhm.
Like zebra net, they put a color on the zebras.
Yeah. I know the story, but however, for this kind of animal, it is very dangerous.
Oh,
Because
you might kill them.
if you put this kind of tools, sometimes they will be, it's too concerned to the animal. Sometimes it cannot move, and then will be die. Then it will die. So this should be very careful. So actually, we want to do the device-free detection. Okay, and we also want to use some other sensors, for example, vibration sensors or some ultrasound sensors to do this research. Oops. Okay. They are my students. They are deploy some devices around the monkeys. This is.
Yeah, they are so friendly with the people.
Sure, that's why we first do the detecting of these monkeys. Okay. Yeah. It's very gentle. Yeah. And if we remove all the devices, that's the traditional way to monitoring those monkeys. You just look at them, and actually you do not just simply look at them. You need to distinguish them using your eyes. So some students from Northwest University,
Yeah.
they do the same same research, but they just use VIS to do the monitoring.
Okay.
Yeah.
So here, this is an interesting project, but technically, it's not our strength, right? I would say.
So what is my plan? Well, my plan is, first we want to do the basic, the fundamental experiment. We want to get the ground truth to prove the feasibility of using this kind of techniques.
So how are you planning to use Wi-Fi to monitor these things?
Maybe we can use other spectrums to do the same surveillance.
So basically, what do you want to know about that? Like the location or activity or are they drinking or those things, right?
Yeah. So for example, for the behavior detection, we can use the Wi-Fi devicefree Wi-Fi device, and maybe for the
that's not easy,
accurate
right?
localization, maybe we have to use the video camera.
Yeah, that's what I think. Maybe
Yeah.
video camera is the best way.
Yeah. So that's why we want to do a hybrid way to do this kind of
Yeah,
surveillance.
I'm still curious how RF signal can be used here.
Yeah, so
How large is, how
Yeah, you can, but
large?
it's not really
Our
that
monkeys activate.
accurate.
Very large.
Yeah, I know. It's wild monkeys.
So our first plan is to do the fundamental works, do the feasibility proof and get the ground truth, and then we want to design some cheap device. Then we can produce many of these kind of devices. Then we can do a large scale deployment to do this.
Sure.
This is our second plan. Yeah. And we want to solve the challenges in this kind of development. For example, the energy and the identification. For example, first of all, we need to count the number of the monkeys, and then we need to track them, and then we need to distinguish them, and then we need to identify them. So step by step, we need to do the fine-grained surveillance, and then we need to do some. We need to solve some problems in the communication. For example, we need to achieve it in a real-time way, and we need to guarantee the QoS. We also need to do it in an ad hoc way, because in that case, you can even use the 2G signal. Okay, so no 2G signal here.
So why not using any of the 3D cameras that are available nowadays?
But you need to retrieve the data back. Okay, so we need to. So actually, currently they have some actually not a very successful solution. For example, they use the satellites. Satellites you can use the satellites to get the data back, but it's too expensive. It's so expensive. So the second
LT base station.
Yeah.
Right. That's okay.
Yeah. Well, we have no infrastructure support in that
Sure, no. But you can do portable LTE, so that's also.
Yeah, so maybe we need to try some ad hoc network. For example, the mesh network. We also want to use some drones, to carry some wireless AP to do the forwarding. Okay.
Right.
Yeah. It's also our attacks. Okay. So why we targeted on the monkeys, because they are very gentle. But our next target is the panda. Panda is so sensitive, it's very, very sensitive. If he smells, our kids, just wrong way, you cannot, monitor them in the wild environment. So basically, currently, if we want to monitor, we want to know how many pandas in a certain area,
What is the existing technology people use for that purpose?
we just detect some first,
What?
and
Okay.
some
Yeah.
it's tech waste. Yeah. So we just do some statistics, and then we inputs those values into a specific.
So patterns can have a
value.
color, right?
But you cannot catch them. This is wider pattern. It's not. Yeah. You cannot catch them.
You are not allowed to catch them.
That, I was just gonna say, I'm sure there are people who can easily catch them. But you know, it's not
If you
something
catch
you
them,
want to
somebody
do.
will catch you.
Exactly, I was just gonna say, you know, that.
So that's why we want to do this kind of research. Right. So this is another story because last year, at the end of last year, in this base, actually this is what we call protection base, 5 pilots died. So everybody, you know, very nervous, very nervous about it. So that's the story. Okay, this is. Oh, that's all for my today's talk. Thank you very much.